now. All right, welcome to this evening's meeting in Azure User Group Norway. My name is Jan Egil Ring, and I will be your host for tonight. If you have any questions during the session, feel free to ask them in the chat, and I will make sure to present them to the speaker at the end. The speaker tonight is Matous Rokos. He's a principal solutions architect at Apex Site, which is part of Atria Group, where he designs cloud solutions and cloud adoption strategies, specifically for scalable solutions delivered as software as a service. He's recognized as a Microsoft MVP in Azure for a third time in a row, and he has worked with Azure since the very beginnings of the platform. And tonight he will take us through working with Azure Resource Manager template. So take it away, Matous.
Great, thank you. Just gonna switch to my slides over here. Hopefully they come up pretty soon. Right. So is everything visible? Everything fine?
Yes.
Great. All right. Good evening, everybody. Once again, thanks for joining us this evening or whatever time zone you happen to be at. Especially appreciating that you are giving interest into the slide deck instead of TV or whatever. I don't have a TV, so I will walk you through the slides. And my name is Matous Rokos. I work as a Chief Cloud Solution Architect in Atria Group. And once we covered pretty much the introduction, or Jan Egil covered it for me, so we will move straight away into the agenda. So what we're going to do today, we are going to walk into Azure Resource Manager templates. We're going to do deep dive into that and infrastructure as code. So first of all, we're going to do a quick introduction to Azure Resource Manager for those who haven't seen it yet, or just as quick recap for those who might see it before. We will take a look into the ARM templates and how they work. And also we will walk into some how-to guides and best practices. We will cover what to do and what will help us write our templates in more efficient way. So that's ahead of us. We will do a few demos in Azure Portal, in Visual Studio, and we will take a look into a couple of deployments, and we will cover pretty much everything from how to start writing the templates into all of these best practices. So that's the agenda for today. If you have a question, feel free to write it into the IM window, and I will answer those questions later after the session. Right, so first of all, what actually is the Azure Resource Manager? Plenty of you might have opportunity to get in touch with Azure Resource Manager, either if you know it, if you don't know it. Basically, Azure Resource Manager is the underlying service or set of APIs that sits in the core of Azure, and it takes care of all your resource management, whether you want to deploy things or update things or just delete them whenever you access any activity logs or any sort of other logs. Basically, whenever you want to get any sort of resource properties. The resources basically are set into so-called resource providers. And that can be anything from VMs to storages to containers to virtual networks to cognitive services in Azure to automation runbooks and web applications. Pretty much anything that actually exists in Azure, or actually everything. So basically, every resource that you're going to deploy has this resource provider, which actually talks to the resources and manages them. So that's how ARM basically divides things. Now, basically, you can call it from any clients that you have. So clients are, for example, client is Azure Portal. Client can be your CLI or your PowerShell, but you might also get into some third-party providers that talk to ARM, such as Terraform or Chef or Puppet or Ansible, or whatever actually you're using today to manage your Azure resources has to talk to ARM. So if you don't use any of these services, you can talk directly to HTTP endpoint. All of these services actually talk directly to the endpoint. So then you're basically down on the level of REST API calls to the management.azure.com. And you are also have available Azure Management SDKs in the case that you want to talk to the API in more civilized way. Then basically when you want to leverage ARM in your own software that you are writing. So for example, if application needs to talk to Azure resources to scale them from inside the application, so it's application aware, then this is exactly how you do it. You leverage Azure Management SDK. So this is a short overview of what actually ARM is. Now we're going to deep dive a little bit more into what ARM actually does. So for example, how any request actually lives, what actually happens when you do any sort of request. So first of all, let's see that, for example, I'm sitting here in Oslo, and I want to get this VM which sits in the subscription one, in resource group one, in US, let's say West US data center. So what actually happens in that case is that I, as a user, without knowing it or maybe knowingly, basically talk to underlying API to the management HTTP operation. So basically, what I do is I click the portal, or I write a commandlet, or basically I type it in the CLI. In any way, basically, I want to connect to that VM. I want to get these resource properties. So that's what triggers the HTTP operation. First of all, I have to identify myself as a user. Then I need to verify that I have access to this resource. Then the traffic actually goes to the ARM service. That's actually inside particular region. So basically, it first makes that verification if this is like a successful resource call, if basically I have access to those things or not. So that one's either gonna fail or gonna succeed. So basically, if that succeeds, then it talks to particular resource provider. In this case, it's Azure.compute provider, which gives me basically HTTP response on all the resources that I wanted to kind of list. So in this case, it's gonna tell me that there's a VM and it has these and these properties and stuff like that. It's also going to log that operation, and this is how ARM kind of works in a nutshell. So what actually happens in some more complicated resource, in some more sophisticated calls, is what makes ARM really, really great. So, for example, let's say that I still sit in Oslo, but now I want to talk to my resource group in a subscription one, which has approximately 100 resources, and those resources can be spanned across multiple regions. They can be basically deployed from a template. We will talk about how to write these powerful templates in a second. So basically, let's say that these resources are spread across different regions. So again, I'm going to talk to that management API. Again, I'm going to get HTTP response based on if my request failed or succeeded. Now, basically, it gets registered as a job to the engine, and it talks to multiple resource providers in order to release those resources. Like I said, it's in the different regions. So basically, that management.azure.com endpoint makes sure that I end up in the proper region. So it always sends my request into the closest one and then into the data centers where the resources actually are. So in that case, I always get the fastest response. So although I'm talking to, for example, resources in Australia or in the US, it doesn't matter for, let's say, because I'm getting answers from API endpoint in Europe, which actually then communicates to particular resource providers in particular data centers. Now, the operation of getting resources is actually streamlined. So regardless how many resources you are accessing or deploying, it's actually creating a parallel action, which is particularly useful for deploying large sets of templates and large sets of resources. So basically, whatever resources we do, it's going to be parallel deployment. So creating 1,000 VMs takes the same time as deploying as one. So we're going to walk through these things and how to actually write them. And at the end of the day, I get again like HTTP response, which talks which displays the action that I created. So this is actually part of the granular scope how Azure Resource Manager accesses things. So at the beginning, there's a subscription, and subscription has some sort of ID to identify you as a unique customer. Then you have your deployments divided into the resource groups with a particular name. And under those resource groups, there are these providers sitting. So basically, then we are talking about again, like into the Azure.compute provider or Azure.network provider, storage provider, and that goes into the particular resources in this granular level scope. So this is how we talk to resources, regardless if you want to just read them or create them. When we write templates, this is something that we need to keep in mind, because then we're going to talk into to particular resource providers in order to create our resources. So another benefit of it is that ARM actually keeps the same model in Azure. So basically in Azure, you basically deploy a template and it talks to the Management API to Azure Resource Manager, and it calls Microsoft.compute provider to deploy these particular resources, in this example VMs. But then again, in the same execution model is actually available in Azure Stack. So Azure Stack just have a different named provider, but it deploys the same set of resources into the Azure Stack. So what you can do is use the same set of templates for Azure and Azure Stack if you have those environments, with just swap of a resource provider, which can be like a condition at the beginning of your template. So basically you can have consistent deployment strategies and consistent deployment experience across Azure Stack and Azure. Now, if you have been working with Azure for a longer time, then you might remember something which was named Classic Model or ASM, Azure Service Management. And in this case, for example, deploying of the resource, like deploying of VM, was fairly limited action. It used to be basically deployed into the container called Cloud Service, which provided you with management IP address and internal IP address that was in a subnet, and then it had some storage account with disk inside. It also created a load balancer with public IP, regardless if you had a single or multiple instances, and that was the experience. However, in Azure Resource Manager, the whole experience works slightly different. So you deploy all the resources into the resource group, which is kind of like your logical container, which maintains all the resources together from a perspective of identity access, logging, billing, and all the other things and stuff like that. But then you deploy these resources, like we mentioned, in parallel. And since you deploy these resources in parallel, basically deploying a VM from a template needs to be treated in a specific way. Because, like I mentioned, all the resources get spin up pretty fast. And if you're going to deploy the resources as a parallel action, then you might end up basically with the VM complaining about, hey, I supposed to set up this disk that I'm going to write my operating system to, but I can't find the disk because maybe it haven't deployed yet. So what you do there is you specify in the template, you specify dependencies. So for example, this VM is dependent on a disk. So in that case, you can make sure that VM always going to wait until the disk is gonna get deployed. When you deploy these things from Portal, you don't necessarily need to watch these things because Portal calls templates for you. But if you want to do more complex deployments from multiple VMs, which you can't achieve simply in the Portal, then you gotta watch these things. Then another thing actually that you have is to specify is a specification of references. So VM has a reference to a NIC adapter because again it's got a tough dependency on that one. NIC adapter has a reference on public IP address or internal IP address and the VNet and a subnet. Then you might deploy the load balancer, which again might need dependency on the NIC adapter as well as IP address of that load balancer. So these are the references that basically you need to keep in mind while you're creating such things. It goes as well into the security aspect of stuff. So basically then you, for example, deploy a network security group, which takes care of your port access in and out and their priorities. So that's got to be linked into the NIC adapter again, or into the subnet. So when we're going to write a code for these things, we got to keep these things in mind. There are some powerful tools that are going to help us with that. There's IntelliSense and there's Visual Studio JSON outline, which is gonna help you us. But still, we need to take care of these things. We need to keep that in mind. The whole thing kind of gives us the whole power of repeatability, so we can basically push all that stuff into the template and make sure that we have very orchestrated way of deploying things with all the dependencies listed in there. So this is our configuration baseline for our production applications that can specify multiple resources, multiple resource groups, spanning across the different regions, and we can deploy this thing without clicking too much, without creating resources from the portal. So if you step away from the mouse, then nobody gets hurt. Great. We're gonna write those things. So basically, this gives us another sort of approach. Then when we don't have to treat our virtual machines as pets and give them funny names and cry when they die. If we templatize the whole deployment, then we basically can create, we can treat them like cattle. 1,000 comes, 1,000 dies, and nobody cares. And if something gets screwed up, then we can just redeploy the whole thing from a template and be fine again. Right, let's do a demo. Let's do a demo of some scalable application. Let's see how we deploy scalable applications. So I'm going to switch to the Azure portal in here. And here on my dashboard, I have pinned this resource group with the VM scale sets on it. Now, this is very infrastructure as a service-based approach, just to keep it familiar with the resources that we know, like VMs, but we can also achieve the scalable apps in lots of other ways, in more cloud-native way, for example, on web apps. But I use this example because I wanted to show how many resources we can actually deploy inside one template. So you can see that this is like a compute-heavy scenario. It runs in scale sets, and it also has lots of dependencies on different storage accounts, on the load balancer, on the public IP, and on the VNet, and basically the whole thing got deployed as one template. Now, so I didn't have to touch any of these things. I didn't have to go to the portal. I didn't have to create anything. This contains all of these resources, order of the deployment, so including the dependencies, and the application configuration. So it actually, this is what the application is. It's just a simple ASP.NET application showing me the name of my scaleset instance. So if I'm gonna refresh it a couple times, then maybe it's gonna change name to the different instance. There you go. So you actually see that you are in a very scalable environment. This is basically the different names of the VMs pop up as I scroll through the site, pretty much. So basically, now we're gonna take a look on how this thing actually happened, because you saw that basically we deployed lots of things. We deployed that VNet and a subnet. That's what needed to happen. Then we configured a storage account. We had to configure a public IP optionally with the DNS record, the load balancer and its configuration, and then we deployed that VM scale set. We have to set up some scaling rules, because you've seen that on the web application they actually changed the URL, so you have some scaling rules applied, which is particularly useful for not just this scenario, but even scenarios like a Black Friday in the eShop, when lots of people come and they need to be sure that they get served properly. But also you don't want to pay for over-provisioned infrastructure, so these servers basically scale up and down as the people come in here, and you always pay only for what you use. Now, the last step that we needed to perform was that configuration and the web app deployment, because by default, it would just spin up VM scale sets with a clean operating system out of the latest Azure image. But I actually wanted to go to my GitHub and grab the configuration out of there as a PowerShell script, and grab the web application as well. So now we're going to take a look into how this thing actually happened, because it's not one thing to see it in demo, but what's actually behind the scene. So first of all, you don't have to be afraid of any of these things if you haven't seen it anywhere before in terms of ARM templates. Okay, actually, let me just show you the code in there. So the great thing about Azure Resource Manager is that you can always review your deployment. So you can, if you are in the resource group, and even if some of your colleagues deployed that or somebody else did it, regardless if it was from Portal or from PowerShell, or from Visual Studio or from any other source, you can always go to deployments in here and display this one. So we actually see that this deployed all the resources that we mentioned. And in the template section, we can actually see the whole template. It's divided into the several sections that we're gonna go through in just a couple minutes, and you can see that this is actually about the storage accounts and the virtual networks and stuff like that we covered, and all the other resources that we had in there. And as you can see from a template how it's actually written, then it's a JSON. So it's basically just a structured document in JSON describing the API calls that you need to create. Now, you don't have to be afraid of this thing. It's just an API. It's just an API definition in JSON. So you can call that API in whatever favorite sources that you have. You don't necessarily have to use purely templates. It's highly recommended, but you can use other tools that you might like. So any REST-capable tools will do the trick. If you don't want to do REST as it is, because it might be complicated for you to do just HTTP calls and things like that, you can always handle PowerShell or CLI. Whatever you like better. You can do the even higher level with Azure SDK, and same thing goes for Azure Portal. You can basically when you talk to Azure Portal, you'd already talk to the same API. So whatever works, but the templates works the best for these massive deployments. And we're gonna continue in basically what we can do with templates. Now, one thing actually is there, the great inspiration where to when to get resources from, and basically the first kind of intro into how to write templates is particularly useful to see how Azure actually sees those resources. So I showed you the templates before, but another thing that you can actually do is to display all services in here and search for resource. And there's a little thing called Resource Explorer. So this is something built into the Azure portal, which allows you to see resources in exactly the same way as Azure sees them. So you can see that this is divided into the subscription and providers. So for example, I can click the providers here, and it's going to display all the providers that I have. And I can scroll here into Microsoft.compute and, for example, display my virtual machine scale sets. And there you actually see that that basically how these scale sets are there created. So it goes through all the regions and all the API versions that I have my scale sets in, potentially zones and things like that. And this is basically what Azure sees in the same way when you go to the virtual machine scale set tabs and display all the resources there. Now, a little bit more useful view is when you go to subscriptions and you display one of these subscription, and in the resource groups, you can actually see the resource group as in the same way as you have them. So if I'm gonna go here and check this resource group, I should be able to find exactly the one that I have, if I wouldn't be blind particularly. There we go. So there then you basically can display all the resources that you have in there. So I'm gonna click that one. It's sorted into the resource providers again. And this was the same view as I was capable of seeing from the portal before. So basically there you see that I have currently scale set as capacity of 2 because I scaled down when I didn't need my resources. You can see that this is Windows Server 2016, the latest version of the image, meaning it's got all the security updates and stuff like that, so I don't have to worry about that. And it's got extension profile, which I will cover a little bit later, but this is something that allowed me to grab the content from my GitHub and deploy it IIS and the web application. So this is something that served as a great resource for writing a templates in the first place. And we can go a little bit into the structure of how it is in the template. So basically when we open up the Visual Studio, then you basically have this overview. I can click this my first template solution. And if I'm gonna write something like that, you can actually see that I have by default several sections, which is contained out of schema, out of parameters, variables, resources, and outputs. So let's briefly walk through them. So it's like every other JSON document. It has a schema. The good thing is that you don't have to worry about the schema at all, because that's something that is given by Microsoft. So it is something that is automatically created at the beginning of all templates. Now we get parameter section, and the parameter section is there for things that require some input from whoever deploys these things. So if you need to ask things for deployment, such as what is your administrator username, or what naming convention you're going to use, what's the name of that resource that you want to specify, something like that, that you actually want somebody who deploys these things to specify. If you don't want them to specify that, then you parse these resources into variables. This is where you keep them. This is the middle section of the template. So basically, you keep those resources, those names and stuff like that, and the details and IDs and that stuff like that you don't want people to change. You keep them in there, and that's what allows later section in resources to grab them. And resources are basically any other Azure resources, like storage accounts, like virtual machines, like web apps, like cognitive services, anything that you really can come up with for what you use in Azure. And that basically keeps the structure of the resource and some configuration aspects of it. So it basically takes all the properties that you want to resource to have, and it keeps them in that template and the structure to deploy. So you can grab all these parameters and variables and parse them into the resources. Now, the good thing with parameters is that you can, for example, use a default values. So it doesn't have to be just a manual input, but you can specify a default and allowed values, so which is specifically useful for example, choosing the operating system or Azure instance when it's particularly easy to make typos, and your template would get refused with typos because it's case sensitive. But if you put allowed values, then it's going to display a drop-down menu. So how do we get started? Well, there's a pretty wide range of templates that you can start with. The one other thing is that you don't have to start with pre-configured templates, but you can basically always display how Azure sees those resources. And these templates for a quick start are indexed on azure.com and on the GitHub repo as well. So you can go to the GitHub repository called Azure Quick Start Templates and grab some source of inspiration for a start. This repository is actually community and Microsoft driven and contributed. And you can actually put some of your templates in there as well if you want to give example to others. So this is the URL for the whole repository when you can grab your quick start templates. So lots of examples in there. Right. So let's talk more about how we got that app running in that scale set, because we had to push some code in there. We had to do some configuration up there. So how do we do it inside a template? So there is this thing called VM extensions, which is basically a component of the virtual machine. And that allows you to talk to Azure Agent, which is on that particular machine, which handles drivers and stuff like that, and always has local system access and or root access, or if you're talking to Linux VM. That particular agent allows you to run scripts against that or read particular details out of that, such as logs and performance logs or any logs of that VM. And in this case, what I did is I pushed a PowerShell script into that agent, and the agent executed installation of IIS, the web server, and then it grabbed the website out of my GitHub repository and pushed it inside. But you can do a lot more stuff than that. You can actually use Docker extension to push containers into your VM. You can use a variety of security VMs for malware scanning. You can use PowerShell DSC, Visual Studio Debugger extension, Puppet extension, Chef extension, lots of things that you can actually play with extensions. So you don't have to log into every VM and perform some actions on that, but you basically just push automated actions to the agent. And you can do it inside the templates, of course. That's what I had there. And that's what makes your deployments even more powerful. So let's see how we build an ARM template in a more complex way. So I already started here in the Visual Studio, and now basically what I need to have is some resources coming in there. So this is JSON outlined, and of course it doesn't work because this is a demo. So I haven't prayed to demo gods very much. Let me just try to open up a new project. By the way, this is how you do it. You open up the new project, you go to the Azure Resource Group. Let me just create this one. And we can we can go to the blank template because we're gonna write it from the scratch. Let's see if JSON outline is on our side this time. You get to open up the main template file, and yes, JSON outline got refreshed, so yeah, good. Demo got saved me. So what I want to do here is I want to click this new button, and I can search for certain resources. So this is examples of, sorry, I'm not going to scroll too fast. This is an example of few resources that are actually there. So for example, you can create VMs and logic apps, and these are the extensions for those VMs. You can even create a nested deployment. This is something that we're going to talk about a little bit later. And I'm going to scroll down to the VM in here. I'm just going to create a Windows virtual machine. I'm going to name it my VM, but this is just for the context of a template. It's not actual name of that VM. Storage account, I'm going to create a new one. You can also see that the JSON outline helps you out with picking up existing VM from a subscription or existing storage account from a subscription or from another template. So I'm going to click on create new. I'm going to name it storage account SSA. So then it's going to be added to the template. You already see that this one got added into the template for me. Same thing, I go with virtual network. I'm going to create a new one. This one's going to be VNet. So again, it gets added to the subscription. I'm going to click add, and then you actually see that it created the virtual machine for me with its NIC virtual network and storage accounts. And you see that these are the properties of the virtual machine. So I'm calling Microsoft.compute resource provider and picking up the location of the resource group. This is a smart function that we're going to discuss. We're going to talk about more about functions later on. And this is all the properties that I'm getting. So it's figured out which operating system to use, which username to use and stuff like that. Now these things you can see it grabs out of parameters. So it was smart enough to create parameters for me with asking for administrator username and password, and with asking for OS version. Now how these things actually going to look like when I'm going to deploy it. If I'm going to deploy from Visual Studio, I just click here, hit deploy, and create a new deployment. It's going to ask me for my credentials, but in this case it actually remembers them. So it's just going to grab my my subscription list. That can take a while because I have some subscriptions up there. By the way, you can also deploy a template out of Azure Portal or out of PowerShell or CLI, or you can add it as a part of your existing CI/CD pipelines. Well, this one takes a while, so what I'm going to do is I can try it again, and if it's not going to work, then I can always grab it in the portal. There we go. So here I can see the list of all my resource groups. I'm going to create a new one for this deployment, which is going to be called Azure Resource Group. Let's call it Azure User Group Norway. We're going to deploy it in the West Europe. Let's create that one. By the way, you can actually put the resource group creation into the template as well. And when I have these parameters in here, you can actually see that these things it offers me as a drop-down menu because these contains only allowed values. My VM name is going to be like my VM. This is something I'm asked to fill in manually. This is my password in there. So it actually asked me to put the username and password. And it actually offers me a OS version as a drop-down menu. So this is something I can save. When I actually save these things, it actually creates a parameter file for me. So this is something that goes with the template file, and you can actually rotate a multiple parameter files based on deployment that you use, or just supply parameters as you deploy. Now, how did we achieve, for example, the drop-down thing? Was that basically we specify always the type, as with any variables in any programming language. We specify the type of the variable, and we specify if we want to have default values and allowed values in there, which allows put us in there more of these things. So, for example, these things only allows to do Windows deployments, and this is how you can parameterize your deployments and use them later on. So this was just a simple short example of how to build templates. Now for the management part, basically like from sources of deployment, like I said, you can call the template out of Azure Portal. You can also call it out of PowerShell or CLI. There are commandlets for it. Actually, sometimes it's best to test it out this way. You can do it from both Visual Studio and Visual Studio Code, and as well you can integrate these things into Visual Studio, what used to be called Team Services. Now it's called Azure DevOps. It's a service which changes names most often. So Azure DevOps CI/CD pipelines, for example. Now let's talk a little bit more about these parameters and how to work with them. So in every parameters, you have to have a specified type, which can be either string or secure string, or all the other types. The difference between string and secure string is that the secure string is used for passwords, and it doesn't get logged into any Azure ARM logs or either basically in your Visual Studio. So that's something how you can protect your passwords so you wouldn't send them over as plain text. You can also create arrays or objects grabbing from other templates, which is particularly useful. So let's take a look on how we work with parameters. I already showed you a little bit in there. So you can, for example, see that that this one has only allowed values, while my username is a string and my admin password is a secured string. And if I have my OS versions, this is where I get my allowed version and the default version. Let's see that if I would like to add one, so for example that I know that Windows 2016 also is out there, so I might want that one. So that would be 2016 Center. And actually, I would like the 2016 data center to be my default one, so I'm going to swap the default value in here. Now, if I'm going to deploy these things, you can see that these things actually changed in there. So if I'm going to do deployment, it's going to offer me the new default value first. Yeah, there we go. So another great thing that I can actually do with that before deploying it from the Visual Studio is that I can copy the whole thing as somebody would go in the Azure portal, and I can go to here and create a new resource for somebody who's more friendly with the portal. I can go and put it into the template deployment in here. I'm going to create a new one. Build your own template and editor. Now you can actually see that this one, this editor is very similar to the one that we've seen in Visual Studio. They basically try to keep it unified. You again have some helper here in terms of adding more resources, but I'm just gonna paste all of that. Now in a while you will see that it actually creates the whole same structure as I had in Visual Studio. I can save it. And again, in this section, it offers me exactly the same parameters, including my default 2016 data center server and basically all the parameters that I wanted to have. Now let's talk about more tips for parameters. Parameter doesn't have to be only about allowed values and default values, but it can actually consist out of, for example, allowed minimal and maximal value. It can optimize the minimum and maximum length, and it also can contain the description. So if I want to add description to my parameters, saying, for example, how to work with them, then this is something that I can add into that as well. Now there are some functions inside the template that actually help you do work with templates in a bit smarter way. So for example, if you want to create some naming convention, you can use it during using concatenate function, which puts together your naming infix and always the resource name that you select in there. Another a little bit smarter functions we're going to cover. So for example, the grade function is toLower, which is specifically used for your naming infixes. If you're going to name your resources, that some resources are actually case sensitive and don't allow to have uppercase characters, such as this is specifically required for resources that publishing up their DNS names. So this is something that you can treat your templates with. So even if somebody goes to the resource and names it during the deployment, your deployment will not fail because it will get treated that way. So let's look into the demo how we correct one of the production templates. I will go out of here, discard all of that, and I will just go to my dashboard in here, and this is our production application. This is actually a template that I grabbed out of the Quick Start repository. And you can see that it's a simple deployment consisting of web application service plan, and a SQL database. In this case, it's a MySQL. And the great benefit of ARM is always look into the deployment, how it actually happened. So you can see that there have been 2 deployments, and one of them failed and one of them succeeded. So I can look into the previous one, and it's gonna list out the overview. So I can see that it was fine on deploying the websites and website application plan, but it had a conflict on the SQL DB. So I can look into the operation details, and I see that this is invalid server name, that basically only lowercase characters and numbers are allowed in there. Well, but I might not know that, because I grabbed that template out of Quick Start repository. So let's actually see that how that template is written. So I will go down into the parameters in here and go to database SKU name, and I will look for the SQL name. So how does the SQL name gets through? I will look into the resource in here and see the name gets from database SKU name. So this is just a string. So nothing's gonna stop me when I want to write uppercase characters into that one. So I will take a look into inputs, what actually happened inside a template and what parameter was been parsed. And it's not gonna show up in here because I did the deployment a while ago, but I can be pretty much sure that somebody typed into the wrong characters in there, the wrong letters. So how can I treat the template a little bit better? It's not to happen again. So I'm gonna display another deployment in here. I can see, and then in this case, the overview showed me that everything happened just fine. And I can go into the template and see what actually changed there. So now I can see that for the name, I still use the database SKU name, but I managed to treat the database SKU name in a specific way. So in a database name now, or in the server name, I'm using function which is named to lower. So it basically grabs the parameters, and whatever it puts in there into the site name, it automatically creates lower characters out of that one. So even if somebody goes there and writes uppercase characters for my resource, it's going to automatically lower them for the SQL Server, which is colliding. So what you actually can see in the overview of the whole resource group is that this function allowed me to be perfectly fine with uppercase character in the web app, but in the server name, it actually created a lowercase character if I go to the server name in the main resource. So in the database name, it's fine. In the web application name, it's fine. But the server name is actually using the lowercase characters in here. Another great function that you can use inside of templates is trim. So if you know that some resources are sensitive for a name length, you can actually trim the name to a specific length. The great value of ARM, it always watches how much the name needs to be trimmed. So it doesn't need you to specify it. It basically will watch it for you. So if you, for example, know that the VM cannot have more than 15 characters in the name, the trim function is going to handle that for you. Even better function to use is to write some unique names. So, for example, every name such as SQL Server or DNS for your storage accounts and on your web applications, stuff like that, they need to have a unique name. And if the name not going to be unique, then your deployment is going to fail, which is something that you will not learn from the writing of a template, but slightly afterwards, which can be confusing and not so pleasant. But you can ensure that the name of your storage account or other unique name is always unique if you use unique string name and for example, call it to the resource group ID. The resource group ID is always unique. So it's basically going to combine your naming infix with that part of the ID and create always the unique name. Another great function that you can use is to list keys. So some of the resources requiring to actually access particular keys. If you want to work with the insights, such as files in the storage accounts, or blobs in the storage accounts, or tables in the storage accounts. So in these examples, you need to list keys. So this is something that you don't have to do outside of a template and then parse it through. You can do it in template directly and just work with these keys as variables later on. A function which is there, which is not used that often as it deserves, is a reference. So if you have dependency on the resource that already exists inside a subscription, or in basically another resource group that you have access to, then you can specify a reference to it. In that case, you can basically add existing, you can add resources to existing resource. One specifically useful function that I already had in my basic template to show you in the start was location. You can basically call the resource group and ask for a location, and in this case, it's going to deploy the resources in exactly the same location as the resource group is. So you don't have to specify the location for the resources manually, such as Western Europe and stuff like that. Now, one of the questions that I get pretty often is if I can lock down the template. Like if you can write a template, it's great, but I showed you how I can display all the templates in the resource group from a long history. So if I can lock it down, if I, for example, do the deployment for my client and I don't want him to see what's inside the deployment. So there's one option called Azure Managed Applications. I'm going to show you that one. And that basically allows us to create the whole managed application definitions. I have one here. And in this scenario, I created a managed storage application, which is ready to be deployed from its definition. And then the deployment looks quite differently. It takes us through the steps which is a way nicer look than the template itself. And it's more friendly for somebody who just deploys the application. You can just pick the resource group in here or create a new one. I'm going to pick the existing one that was user group. But since this Manage application needs a separate one, I'm going to create a separate one there. This is something also that you can be treated. And I'm going to put it into the North Europe. Just confirm that. And this is basically how it goes through the steps. And now it's see that it's asked for me parameters that I specified, and nowhere in this steps I can see the template itself like I could see in the template deployment. I'm gonna skip these things, and basically this is my service catalog, and this is shared inside the organization or outside the organization, and it's managed on the resource level without me accessing the resources or having access to the files or source code during deployment. Now, if you are going to deep dive into a little bit more into what Manage application actually is, it's just a template that you specified. You create another JSON file which is called create UI definition. That definition allows me to go through all these steps through the deployment. Like as you see, it was nice looking 3 steps. The whole thing is packaged inside a zip and shipped over to Azure. So what I can add along with it is a configuration that, for example, allowed me to specify that I can't deploy these things into existing resource groups, since it actually creates application log, so I can't delete those resources, and it creates application access on principal ID and role definitions for existing users or groups. So this is something that you can create for your clients or inside the organization when you don't want people to touch your deployments. Another great thing that you can actually do is to link templates together. So one template can call additional templates, which is specifically used for more complex nested deployments. So if you, for example, deploy a domain controller, and you can deploy it as a standalone domain controller, or you can deploy a domain controller as a part of like larger applications. So for example, if you deploy SQL always on, which you need to domain join, then you need to deploy this domain controller first, and then deploy the SQL and configure it. So we're gonna look into a nested template scenario. I'm gonna go over into my GitHub in here, and here I have my domain controller provisioning. So in this file, how to call this template, you actually see that this is a nested deployment, because when I'm gonna scroll down in here, you can see that this one actually deploys the virtual network with its subnets and storage account, and then it doesn't call another resources, but it actually does Microsoft data resource deployments, and it deploys the whole separate template for it, which grabs from the same GitHub repository. So this is my configure DC template, which actually deploys that particular virtual machine with the OS profile and operating system of your choosing, and then it actually configures the same thing through the VM extension. Then when it pushes the PowerShell DSC file to configure the domain controller as I need. So this is some more complex scenario what you can actually create, and you can call this template for multiple sources when you either need it a standalone domain controller or domain controller as a part of the application. Now, some of the latest improvements includes more improved error handling. So if you are afraid of doing changes on your production and basically deploying stuff into the resource group where your production is, then you can actually do parameters in PowerShell or CLI that allows you to do a rollback action. So if you are not sure with your deployment that much, didn't test it properly, and are afraid of redeploying things, then if there's any error, any compromised resource or anything, then it's going to roll back to the previous specified deployment, which you can just handle by deployment name. The only condition is that the previous deployment have to be successful, so you can roll into that. So this is pretty much wrapping it up. So what have we learned? We walked through some simple and more complex scenario of how we can talk to Azure and how Azure talks to us. We learned how protect our templates so they wouldn't fail. We covered some more complex deployment scenarios and how to handle them. And there's one last demo that I wanted to show what ARM actually allows you to do. So let me switch to the portal for one more time. And I'm gonna search in here for my logic apps. And I have my logic apps named I'm Watcher. We had a session on logic apps 2 weeks ago. I believe that you can access the recordings if you are more interested into how to work with logic apps. But logic apps essentially is a serverless workflow which allows you to do lots of steps in a very serverless event-driven way. So in this scenario, I'm using this logic apps to control my ARM resources and learn about the changes. So we're just waiting for that one to come up. So I'm using Event Grid, which actually checks my resource group name. In this case, it's a resource group which contains my web app and MS SQL. And I'm checking if any action succeeds on that one. So if anyone goes there and successfully change any parameters of the resources that I've deployed, it's gonna check the resource. So it's gonna read it. And it's gonna compare it to my JSON in the Azure storage that I've saved. So basically, after I deployed my resources, I saved this JSON definition of how they looked like when I deployed them. And now, basically, if any changes happen, it's gonna read the resource, compare it to the content of a JSON, and if that configuration is different, then it's gonna send me an email like, hey, there is some inconsistency in your resources. Or what you can do even with that is, for example, add another action and go here and display Azure resource manager. And you can, for example, decide to correct that. So you can do template deployment. Can create or update template deployment, and in this scenario, you would just like pick up the template file, pick up the resource group, set all the parameters that you need, and just correct that action if and get your resources to previous state. So that was my last demo. Thanks a lot for everything. If you want to check out some of the new stuff, I'm tweeting about some Azure announcements. I have lots of examples on my GitHub, so feel free to go into that. And that's all for our session. And now I will go to the questions.
Perfect. I posted a couple of questions here. Question number one, is it possible to lock down portal actions in scenarios where a customer wants to do all resource deployments via ARM templates or code? Yeah,
it's totally possible. It depends on your user privileges. So it basically in the role definition, you can specify everyone as a reader, for example. So in that way, then they don't perform any actions. Or you can specify them as contributors, which allows them only a certain list of actions. So for example, for your testers, you can deploy a predefined application from a template and then lock down these people into contributor roles. So for example, they can restart the VMs, but they can't resize them or delete them or any of these actions. So every action from ARM is available on whitelist or blacklist, depends on the role definition and the role assignment that you have for your users.
Well, have you seen anyone go that far?
I've seen some of these restrictions for test environments, for example, so you have a different set of rules on production and test environments.
Yeah, cool. Second question is, what's your take on Terraform, and what do you see most people use for deploying resources in Azure, such as ARM, Terraform, CLI, PowerShell, Portal, and other methods?
Okay, so I work with lots of people they work with ARM templates because it's an easy way how to write these things. The second biggest group I would say is PowerShell because of course, like lots of people know PowerShell and they want to continue with that way in Azure. But PowerShell can be more trickier to write for more complex deployments. So because you actually have to write some error handling into that if you do more complex deployments, meanwhile in the template you don't have to. Mm-hmm. So that's a comparison of those easier ones. For Terraform, yeah, absolutely. Terraform fully supports ARM. So Microsoft contributes to that Terraform package. So this is something that you can. This is the same team who writes ARM. Then the same team writes definitions for Terraform. So Terraform is a fully supported way. And if you like Terraform, if you use Terraform, feel free to continue it that way. It basically creates the templates and talks to ARM in exactly the same way.
Perfect. Thank you very much. Are there any other questions? Feel free to ask. See, there are one person typing a message.
Yep.
Yeah, great presentation.
All right.
Yeah,
great.
so
thank you very much.
Yeah.